Today, we are going to talk about blockchain web development and specifically on the Ethereum. And many people think then within the blockchain, there is only one use case, and that's the cryptocurrency, but there is much more to that. And I will give you a step-by-step guide how you can actually create your own blockchain web development application. Before we jump right in, let me introduce myself and maybe give you some of my background. My name is Tomas Mikula, and I'm currently working as a senior front-end engineer at the Brandwatch. I'm also a Udemy instructor. I'm helping people at the Udemy, which is a website for online courses. I currently have 2 courses there. And I'm also helping through my website developers and the community at tomasmikula.com. And together I helped over 100,000 developers around the world. For people who doesn't know about the Brandwatch, it's a suite of comprehensive tools for social media management. And it helps with the monitoring, branding, and also getting edge in the social media space. And currently we are also hiring. There is more than 46 roles. So if it is something interesting for you, that you would like to work in the social media space, you can either visit the website, I leave the link here, or you can just contact me on my work address, which is below, tomasmikula@brandwatch.com, or just connect with me on the LinkedIn and I will point you to the right people. So the most important part of today is why are we actually here and why this topic and how is it relevant to you? I was thinking about it, how to start, and I think a good start is if we look at the Google Trends. Google Trends can show a chart for how much a specific keyword was searched for. So when I searched for the blockchain, you can see that there is a big peak, which is around 2017 year, and it was during the big crypto craze. You probably heard Bitcoin skyrocketing, you probably heard about Ethereum or any other cryptocurrencies, and this was the peak, and then we went in a downtrend. Then there was another smaller peak in 2021, and now you can see we are in the downtrend again. So what this means to you is that now it's actually a great time to learn this technology, because when we come to uptrend again, you better come prepared, because then when the employers start to search for people, then you can come out on top with already knowing the skills and the technology. The next thing is that here I took a look at the blockchain developer salary according to the Glassdoor. And currently it's showing that here's the range between 81 and 135,000 per year. And that's according to the Glassdoor. Of course, this varies a lot, but just to give you an idea what could be the potential salary. Another thing is that I was looking at an article from LinkedIn News, which is made by LinkedIn, and they have been looking at the job postings from 2020 to 2021. And they have seen that the Bitcoin, Ethereum, blockchain, and cryptocurrency jobs with this term in the title, they grew over 400%, which is like incredible growth. And that's just in US alone. So what this means is that there is already demand and there is a huge demand. So if you just go to the LinkedIn and type the blockchain keyword, you can actually see that across the world, there is over 62,000 job postings right now. So you can see there is a huge demand already. So now we can take a look at what is actually blockchain, what is this technology, and how we can leverage it, as web developers. So I have took some definition for you here, and maybe we can just go through it and then look at the key points of this definition. So according to this specific definition, it's saying that blockchain is distributed and decentralized digital ledger that allows multiple parties to record and verify transactions securely and transparently. So in simple terms, it's digital record-keeping system that is managed by a network of computers rather than single authority. So what I want you to remember from this maybe complex definition is mainly these keywords, that it is digital record-keeping system, which is decentralized and secure and transparent. So what it means is there is no single central authority, no super admin who can change something just by their change of mind. I think it's important to understand how the traditional web application looks like. So if you think about this, then usually there is often a database where this data is stored, where the data can be accessed and also available to other people. Then we often have a server, and this server communicates with the database, retrieving the data, manipulating the data, or just presenting it to the user. Then we have a client or front end, which communicates with this server, and usually it's through some API. And then hopefully we have a user, or in the best case, multiple users, and this user uses our application. But this is not all. There's more to this. There is actually a user or an admin who manages this server. So he can make good things, but the problem becomes when he starts having malicious intent, because we never know what is happening to our data behind the scenes, even though when we are acting with the website or with the server. So sometimes the user gets surprised that data was leaked or account was deleted and stuff like this. So it is important to know here that we don't really know when we press the button on the website what is really happening behind the scenes, and if it's happening, what we expect to happen. So this is traditional web application. Now the question is, can we do better than this? If we look at the definition again, we can see that the blockchain is digital record-keeping system, which is decentralized and secure. And this fits really well into our system of the web application. Here I made some comparison between the traditional database and the blockchain. There are many differences, but we will not go through this. I condensed the list and I want you to focus on the main points. So if you look at the traditional database, often it is centralized. There is single authority or company or person who owns this database and has access to it. There's often limited transparency, so you cannot just go and look into the database. You cannot just go and look how your data is stored in the Facebook database. They will not allow you to do it. Of course, it can have reasons which are, some parts can be confidential, makes sense, but you just don't know what is happening behind the scenes. On the other hand, the databases are usually very high performance. These databases can be scaled down and up, and they are usually highly optimized. So they can deliver data really, really fast. So when you are searching for something, for example, on Facebook again, you get the response extremely fast. Compared to the blockchain, blockchain is again decentralized. So what that means, there is not a single person who can just shut down the blockchain. It's not possible because it's decentralized and it's running by multiple computers across the world. It is also transparent. So what that means is that the code itself, the data are visible to everyone. We will talk about the advantages and disadvantages of that as well. And the downside is that it's usually slower. It's significantly slower. So when you try to save something on the blockchain, it takes time. It takes time. So these are the main differences. What I want you to remember, what is the difference between the database and the blockchain itself. So let's look at again at the traditional web application and how we can improve this infrastructure or this architecture of our app. So we can see that the problem is that we have the admin who manages this server and database. So what we can do instead is that we can actually replace these three things with a blockchain. And what we achieved is that now we have actually decentralized web application, and the user is very happy because he knows that no one can shut his account down or change some data or stuff like that. But it's not simple as this. We also have to understand that every application is different. Every application can have different use cases. So what we will need to do, or what we will need to have on top of this blockchain, is also something called smart contract. And we will look at these terms a little bit later. But for now, let's just focus on this, that we will have blockchain, we'll have smart contract, and we will have some way of communicating through the client, with the client, with the smart contract and the blockchain. So for the demonstration purposes, the blockchain will focus on the one called Ethereum. That's the one which we'll be using in this example. We'll look at the smart contract, which will be written in a language which is called Solidity. I will explain that later. And then we'll also look at the API and how to communicate with the client and the smart contract through something called Web3.js. So let's look at what is actually the smart contract. What does it do? How can I use it? And how it helps me. The smart contract, you can imagine, it's not really smart, and it's not even a contract, but what it is actually piece of code which you can deploy and store on the blockchain. That's all it is. The thing with this is that this code is not changeable, so it's immutable. So what you program is what you will have, and that's it. So this includes if you have a variable which you want to change with some function, and you will not program this function, well, then you will never have this functionality and you will never be able to change that variable. So again, what you program is what you will have. That includes bugs. So if you, by mistake, make a bug or code which breaks sometimes, well, then you will have this in the code base living forever. So you can imagine this like code on the GitHub. This code on the GitHub, anyone can go and see. Same with the smart contract. It's transparent. Anyone can go and see this code which you have written, but no one can change it. So if you look at the right side, here I have a sample of how smart contract looks. And if you are a developer yourself, then you can see it's actually very similar to traditional programming language. And that's because Solidity, that's the language which is being used, is also object-oriented language. So you can see on line 1, we have something called Pragma Solidity. And here we are just saying to compiler which version of Solidity we are going to use. Like there are different versions of different libraries, then Solidity also have a versioning system. Then we just specify keyword contract, the name of our contract. And then inside we can have variables, functions, and mostly like classic programming language. There are strings, there are integers, there are objects. On line 14, you can see there's something called struct. You can imagine this like a class in JavaScript or in Java. And you can have variables. Mostly on this slide, we can see there are two, which might be new to you. One is address on line 12. This address is a specific keyword, and usually it's 42 character string. And each participant on the blockchain have a unique address. So we can represent this string with the address keyword. Then we also have a mapping. And mapping, you can imagine like a key value pair in object. So each key points to a value. In this case, I have address pointing to a person. What is important to note here is that interacting with the smart contract, or how Ethereum blockchain works, is that there is a cost associated with it. So when you try to interact, it will cost some Ethereum, but when you're trying to read, that's free. So reading is free from the smart contract, but changing a state, changing a variable, that costs something, but we'll look at it later. There is also a website which I included here. It's called remix.ethereum.org, and they allow you to go inside and play with it. You can do it for free. It's like online IDE. You can write your code, you can test it, you can have like a sample blockchain, you can do it for free. Then I wanted to show you, I'm not sure if you're familiar with CryptoKitties, but I think it was end of 2017. There was this craze about these CryptoKitties being the NFTs, first NFTs on the blockchain. Although it's not true because the first were CryptoPunks, I wanted to show you that they also programmed some code, and this code is actually accessible because we know smart contracts are transparent. So you can go on this website, etherscan.io, you can type CryptoKitties, then you can click contract, click code, and you will be actually to see exactly all code, how CryptoKitties work, and what's the logic there. This also has advantage that the user can go and verify that the code is doing what's supposed to do. What is really important, because smart contracts are at the core of the blockchain logic, is that you can possibly introduce bugs. So it's important to have audits, not only for the reason that these auditor companies, they are helping you to identify these bugs, but they also do in-depth reviews of your code. They can try to optimize your code, and they are well aware of common vulnerabilities. Not only this will help you to avoid mistakes or redeploying your smart contract, but also it gives a trust to the user who are not or does not have knowledge in the blockchain space that independent company reviewed it, and now the smart contract is safe. Now let's look at the example, because I have been talking a little bit about theory, but I also want you to know how to program this yourself. In this example, we'll be looking at the voting system, how we could implement possible voting on the blockchain, having just the front end and blockchain. There's no classic database, there's no backend, we just have front end communicating directly with the blockchain. So we eliminated the part of having the server database and the admin. So the first step when we want to create the web application is actually having the smart contract. So let's start with that. We go to the remix, for example. We say what version of Solidity we want to use, and we specify our smart contract. We call it let's call it voting. Then we think about what we want to have, what objects. Let's say we want to have here a poll. The poll will have some ID, and we'll also store the number of votes. These are just integers. In this case, they have type of uint 16, which means unsigned integers of size 16. Then we have some mappings. We'll have mapping of each ID pointing to an actual poll object, so we can easily perform instant lookups and get our polls, which we want. And we'll also have some event. This is also special to the Solidity. And you can define event and emit this event when you perform something to notify people who are listening or websites who are listening to change something or update something in their UI. And in this event, we're accepting the address, which could be the person who voted. And second would be ID of the poll, to knowing on which poll this person voted. So we have defined the structures, the events, the mappings, all the primitive variables. And I also want you to see that you can take it a step further, and you can have more than just these simple variables. We can have poll, which is multi-choice. We can have start date, end date. So I would say, don't get restricted or afraid of this smart contract. Just go as you would normally would do in your classic programming, and then see if it works for you or if not. That was the step one. We defined the smart contract. And now what we are going to do is actually look at something called MetaMask. And we need a way to connect to our smart contract. And MetaMask is what helps us with that. What is MetaMask is that it's a browser extension. Again, it's for free. And it helps you to connect with the Ethereum blockchain directly, just through your browser. So it helps you connect with this decentralized web application, and you can get it on metamask.io. It's really helpful. The next step is that we have the smart contract, we have the MetaMask, the browser extension, and now let's look at the front end and our middleware. The first step in our front end application is that we need to install the package, which is called Web3. And what Web3 is just JavaScript API for the Ethereum. So it provides some helpful functions and methods which you can use to connect and execute some transactions. This you can get for free on NPM package library, and you can install it to your Angular application or React application, doesn't matter. The first step is to install this library. And then the next step is actually use this library. So in here, I'm going to use Angular, and I'm just creating classic Angular service. But what you can notice on the top is that I'm importing this library because we'll use it later. And I'm also importing a contract from Web3 ETH contract. This library is also installed when you install the Web3. So the first step is to define some variables. We need the Web3 variable, we need the contract variable, and we also need contract address. Because when you build your smart contract and when you deploy to the blockchain, you will actually get an address where it lives. So you need this address to insert it into your service so it can find it on the blockchain. The next step is in the constructor. We are going to initialize this connection to our Web3. And this means, you can see on the line 18, I'm checking if Web3 exists on window. And this we can know that if user is using MetaMask, then this Web3 will be injected to the window. We know he's using MetaMask, and then we can continue to initialize the contract on the line 19 and 20. And what is important here is that there are two variables on line 21 and 22. One is the actual contract address. Again, this we will get when we deploy the contract. And there is something new, which is called contract ABI. ABI stands for Application Binary Interface. And this you can get from the Remix website. So when you develop your smart contract, at the bottom, you can generate this ABI, which is just interface for the Web3.js library. And it's just big JSON, and you can copy paste it to your code. So this, once you're done with the development of smart contract, get the ABI and use it in your front-end web app. And then we activate our connection with the window.ethereum.enable, and just in case catch some errors if something goes wrong. The last thing is that we actually need to implement the functionality of performing this blockchain functionality and transaction. And we do that by calling our contract, which we initialized just before, and calling methods property. And in here, we need to have in the square brackets the name of our function. And I think I actually forgot to show it, but I think I should have it here. That in the smart contract, we also created this vote function. And this vote function takes just one parameter, which is the poll ID on which poll you want to vote. And then it has 3 lines. So maybe let's look at this first. So on the line 19, there is a require statement. And you can think about this require just as having an if statement. So if this is not true, meaning this poll ID is not equal to poll, which is already initialized, then we'll just say poll doesn't exist. If it is true and poll exists, we go to line 21, we increase the number of votes for that specific poll. And then on line 23, we just emit event, let other people know something had happened. And for our front-end application, we can react to it. So you can see on the left side that the name of our function has to be exactly same as the string which we pass to the methods. And also the number of parameters needs to be exactly the same as the one how we called the method from the front end. Then we execute the send transaction. And what we can do, we can also listen for certain events such as transaction hash. That means when the function was executed successfully, transaction is created, and we can perform on our front end some UI updates. The last thing from our web development is that, let's say we have to create some poll on our front end. We add some options. Do you like puppies? Yes, of course, sometimes I do. So we click some of the options, we click submit the vote, and this button executes the function on the left here, which I showed you. So when we click that button, what happens is that actually MetaMask extension pops up asking us, do you want to perform this transaction? Because actually when you're interacting with the blockchain, you are actually executing transactions. So we are executing the vote function. We say yes, and then at some point we'll get update and we will see the results. What is important to note here is that these updates, blockchain is very slow. It can take 10 seconds, it can take 30 seconds. So that's the downside. But we can probably use some optimistic UI and show the result immediately, so the user can get some instant feedback. So what we did now, we actually created decentralized web application. We have the user, we have our front end, and this front end is communicating directly with our smart contract through API called Web3.js library. And this is all deployed on the Ethereum blockchain. So now we moved from centralized to decentralized application. So I know this might have been a lot for you, a lot of new terms, a lot of new code. Maybe I went even a little bit fast over it. So I actually have a bonus for you. So for all the people who participated and all the people who are participating in this event, I prepared access or gift for you for the complete blockchain web application development. And this you can get free completely just by scanning the QR code. or going to the website tomasmikula.com/gift. So here you will get access to this course where I go step by step and showing you how you can develop this web application in much more detail in depth by using the Angular for the front-end framework, MetaMask for the glue between the front-end and the blockchain, and then the Ethereum for the blockchain itself. So this course or this gift for you will be available to first 500 people who claims it. I hope you like my talk, and thank you very much for participating. And back to you, maybe Martina.
Thank you, Thomas, for a brilliant presentation. I can see that we already have one question in the chat from Ellie, and she's asking, can you explain what is an NFT as part of the Ethereum blockchain?
Yeah, so thank you for the question, Ellie. So NFT stands for non-fungible token, but what it actually is just a piece of code in the smart contract. Like if you let's look at maybe take a look at the CryptoKitties. These are the NFTs. Yeah, so usually these NFTs are thought about being just JPEGs or some images, but it can be more than that. We can have also different types of NFTs, but mostly now you can probably heard about this NFT craze. But it's just, you can think about it as having your own address uniquely connected to that NFT or to that piece of data on the blockchain. So what it means is that you own this specific object on the blockchain, which in this case can be, for example, a JPEG of a kitty. So no one can take this away from you. It can be only changed when you transfer ownership to another person. So meaning when you sell your NFT, this function of transfer ownership will be executed and the address will be pointed to another person. And that's how actually NFTs work. There was another question, where info is stored all the time. So if we are talking about for example, poll, like where these poll results and poll data will be stored, it will be actually on the blockchain. So let's take a look here. So this code, which you see on the right side, we deploy to the blockchain. And by nature of how blockchain works is that, and that's why it's actually costly, is that blockchain is just kind of like database which lives on the computer who participates in the blockchain. But not only there, but on all computers around the world. So everyone has the copy of the same database. So when you deploy this smart contract, everyone will update in the world to also have the smart contract on the computer. That's why it's also costly to deploy the smart contract. And they will have on their computer all this data. So when you change, when you vote and change the state of votes to +1, then everyone in the world will do the same, update it, and data actually lives in this database being on everyone's computer. So that's why it's important not to store there any sensitive information, any secrets. It should be as used for the data which you think are relevant to have there. So in this case, we had frontend directly communicating with the blockchain, but it could be that you can have some data stored in the blockchain and some data in the database. Like, for example, user passwords, because that would probably not be a good idea to have it on the blockchain because it would be visible to other people as well. Yeah. Can you recommend resources about the topic? Sami is asking. Yes, of course. One of the topics which I'm also looking in my course is giving you ideas on how to start, where to start. So I would highly recommend the course I prepared. But you can also look at the remix.ethereum.org. That's the website which I mentioned. That's basically documentation and showing you how you can develop this smart contract, because I would say this is the first step in your blockchain web development journey to understand how you can program and create a smart contract. If you have no programming experience whatsoever, I would not recommend probably starting there because you need to get a sense of how to program things. But if you already do, if you have some experience with programming, you have this programming mindset, then that's a great place to start. And Lubomir is asking if all sensitive data is hidden from the user and the blockchain, where does it stay? So I was showing you architecture where we have front end communicating directly with the blockchain, but there can be also different architecture that we could have front end, blockchain, and the traditional backend as well. So this is called off-chain place that we are having 50-50. Some data are on the blockchain and some data are in the traditional database. So for example, we could have when user is registering on our website, this data could be living in the traditional database. But when the user is, for example, voting, as in our application, then this data could be stored not in the database, but on the blockchain. So we know that the user feels safe actually voting here because he can go and verify it by himself. This is completely transparent. All this is shown on the blockchain. But to answer your question is that sensitive data should be probably still in the traditional database, but the data which are okay to be in the blockchain, then I would just leave them there. So hope that answer your question, Lubomir. Yeah.
Okay,
Let's see if I missed.
Out of time. If there aren't any questions, what we can do is I can give you a link to Tomas's LinkedIn. You can find him at Tomas Mikula. If you want to continue the conversation and learn more about blockchain development. Once again, thank you very much for joining Career Show Tech. And thank you to everyone who watched.
Thank you too.
Wishing everyone a lovely day. Stay with us for the rest of the sessions of Career Show Tech. Take care, everyone.
Thank you and have a great day. Bye.